Hello friends, and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in checking if a tree is complete or not iteratively. First, let us see what exactly a complete tree means. A complete binary tree is a binary tree in which every level except possibly the last is completely filled and all nodes are as far left as possible. Let us see the algorithm which will assist us in checking whether a given binary tree is complete or not. Let us also have a sample tree to test our algorithm. We pass the root node which is 1 into function is complete bt. So root will point to 1. Now we create an empty queue and create a flag variable which will be set to true when a non-full node is seen. We enqueue the root node which is 1 into the queue. Since queue is not empty, we enter the while loop. As we enter the while loop, we take another node, temp node, which will point to the front element of the queue. Also, the front element will be dequeued. So, temp node will point to 1 and 1 will be dequeued. We check if temp node's left child exists. Now, we check if flag is true. Since it is not, we enqueue the left child of temp node. So, 2 will be enqueued. Next, we check if temp node's right child exists. As it is true, we again check if flag is true. It is not, so we enqueue the right child of 1 which is 3. We continue with the while loop as the queue is not empty. So temp node will point to 2 and 2 will be dequeued. Now we check if 2's left child exists. As it is true, we enqueue the left child of 2 into the queue because flag is false. Next, we check if right child of 2 exists. As 5 is the right child of 2, so 5 is enqueued. We continue with the while loop as queue is not empty. Now, temp node will point to 3 and 3 will be dequeued. We check if 3's left child exists. Since it is true, we enqueue the left child of node 3 which is 6. Now we check if right child of 3 exists. Since it does not exist, we make flag true. We continue with the while loop. Now temp node will point to 4 and 4 will be dequeued. We check if 4 has a left child. As it does not have, we make flag true. Now we check if 4 has a right child. As 4 does not have a right child, flag remains true. Now we continue with the while loop as the queue is not empty. So temp node will point to 5 and 5 will be dequeued. We check if 5 has a left child. As you can see, 5 does not have any child, so flag remains true. The same goes for the right child of 5. Again, we continue with the while loop and now temp node will point to 6 and 6 will be dequeued. As 6 is a leaf node, it does not have left and right child. So flag remains true. Now the queue becomes empty and hence we will come out of the while loop. Then we return true. So this is a complete binary tree. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in our tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.